an educational series on cybersecurity, compliance, and IT governance. Produced with the support of Freedom Technologies, Phoenix's leading managed service provider.
So my group is, what we do is we're part of what we call threat signature services. And we're tasked with what's focused on false negative reduction. So when we have a red team exercise or an actual attack and we didn't detect it, we had those visibility gaps that Justin identified with the tech tool or with MITRE, and we say, we don't have a way to detect this. How can we go about and do that? And so one of the gaps that we identified is that there were a lot of capabilities, a lot of this tool, Yara, was built into a lot of our tool sets, right? It was built into FireEye, it's built into Titanium, it's built into, a lot of open source products. And so when I came into this, my manager was like, we need someone to kind of take this on. And I said, sure, I can do it. So I was voluntold, or I actually just volunteered myself, right? I forgot that old adage when I was in the Navy, that the Navy stands for never again volunteer yourself. Well, I was in the Navy 20 something years ago, so I kind of forgot that. And I said, sure, I can do Yara. And so I dove headfirst into Yara, and it's really interesting because as I started to dive into that, right, I'd heard of it, I had seen presentations on it, but as I started to dive into it, one of the things I realized is that a lot of people have heard of it, but not a lot of people were taking advantage of, even within our environment. Even recently, we came onto a project where we were dealing with MageCart Skimmer, and we didn't have any visibility with that in our tool set. So we reached out to vendors. We said, hey, can you give us a rule for this? And like, no, everywhere we turned. But we detected it with Yara in our environment. However, we wanted to go with that, that belt and suspenders approach, right? We could detect it in FireEye, but again, we're like, well, hey, kind of like what was being said earlier, if I can detect this, well, why can't I prevent it, right? So with FireEye, with our malware detonation sandboxes, we have detection capabilities in place, but we didn't have any preventive capabilities. And so we started looking around. We said, hey, you know what? Our proxies actually have Yara rules built in to do this. And with our proxies, we can actually block that if we see that, if we can write a high fidelity rule, we can actually block that activity. So if we see MageCart, the skimmer, being identified, then why don't we just go ahead and block it? And so I worked with our proxy team, and I started talking to them, and I said, yeah, you guys have this capability, looked at the documentation, and they said, oh yeah, it's enabled. And I said, cool, can we look at those YAR rules you have? And he said, sure. So we downloaded the YAR rules inside of our, that we already have in place, and we opened it up together on a Teams call, and it's completely empty. He's like, oh wow, we're not even doing anything with you. He's like, I've never even seen this. So I kind of walked him through the process of what Yara is, and he's like, yeah, I've never really utilized that. So one of the things that one of the reasons why I put this together is that, and again, I can ask for a show of hands if you guys want to, but it's one of those tools that a lot of people have heard of, but not a lot of people have really taken advantage of and used. But it has a tremendous amount of capabilities, right? It's the Swiss Army knife, or the Swiss knife of the pattern matching Swiss knife, right? And the reason why it's, if you look at the documentation, it's very specific to call it the pattern matching Swiss knife because of, they got into some trouble with copyright infringement and what have, right? So, but the acronym itself stands for Yara, and yet another ridiculous acronym. I've also read yet another recursive acronym. So what does it mean? It doesn't really stand for anything. It's just, the name of the tool. So it's created by Victor M, who is an employee of VirusTotal, and it's available there, at the GitHub from VirusTotal's GitHub repository there, and it just has a lot of very good capabilities, right? It's very well documented. It's there in the read the docs there, and as I said, you can run it as a standalone tool on Windows, Linux, Mac OS. I'm going to be showing hopefully a decent demo with Mac OS, not as detailed as Justin's, but again, just kind of a high-level overview of some of the things you can do with Yara by going in and kind of walking through my process and what I'd like to recommend. Because one of the things that we talk about when we teach some of these SANS classes, one of the biggest issues we have with regards to information security in general is that we look at some of these industry studies, we see that the biggest problems we have are lack of trained personnel and lack of repeatable processes, right? And that gets us into this problem where we have the superstars like Elio and Eric and John and Justin, and they come in and they're like, And I call this the LeBron James effect, right? I think I might have mentioned that before, but I call it the LeBron James effect because LeBron James is an amazing basketball player. And he's so good that he often it often takes away from some of the other players because they always rely on him to take that last shot, to make that perfect pass, to hit the 3-pointer at the end of the game. And that happens to what happens in the industry is a lot of times that happens to us. We have that one person who's just amazing at the keyboard, and we rely on them to do everything, right? People like Justin and Eric and Elio, and they can just do amazing things, and we kind of tend to rely on them, and they automate, and they think differently, and they're constantly looking for ways to improve it. But then they leave the organization because they get a better offer, or they start their own company, or what have you, and then the entire organization goes down because everybody was relying on that one person. Okay, and so again, what we need to do is we need to get better at starting to develop repeatable processes, and then sharing that information, sharing that knowledge, such that when that one person leaves, who is the the superstar, while the entire team can still function and operate and take advantage of their skills, their knowledge. And so what I'll walk through at the end is kind of a process for actually going through the creation of Yara rules, testing, evaluation. It's a real high level process, but again, it's really important to focus on that process of going through and testing your rules, tuning your rules, making them work for your environment. Because again, with the automation process that I'm going to look through, it'll generate a high level rule, but a lot of times that rule can be very broad and generate a large number of false positives. Or it can be very specific, and it's really no better than a file hash, and we know how easy that is to defeat. Okay, so as I said, it's something that's available as a standalone tool for various different operating systems, your main operating system, but it's also integrated into a tremendous number of tools. And I'm finding every day more and more tools that have this capability, right? You have your commercial tools like your FireEye, proxies. Again, you have your open source tools like Cuckoo Sandbox, Volatility, ClamAV. And again, just about most of the commercial tools I'm finding, and most of the functionality I'm seeing out there has some capability to do Yara type of analysis of files, right? But again, when we look at some of the benefits of that, it's pretty easy to understand the syntax, right? It's just looking for certain strings, certain behaviors of families of malware. And so the benefit of this is that it's going to be much better in most cases than just a file hash. Because again, it's very easy for me as if I'm doing any type of red teaming or any type of purple teaming or any type of adversarial based attacks, to go in and just modify the code just slightly so it doesn't exactly match that hash. However, the behaviors of that malware, the underlying capabilities, and what imports get loaded, what DLLs get called, what images get loaded, all that is going to be very similar for certain pieces of malware. Even if I've changed the hash 53,000 times and I've modified and I've packed it and I've done whatever, there's going to be certain function calls that occur over and over and over again, and certain things I can look for. And that's one of the benefits of Yara, that it says, okay, hey, look at this and say, okay, what are some of the strings? What are some of the locations of certain hex characters, certain strings, certain executables, certain capabilities that we can take advantage of to really identify this particular family of malware, whether it be Ryuk or Emotet or MageCart, like I said, or whatever. This can be a tremendous capability, much more beneficial than just something like a file hash, right? So again, it looks for tools that are created by the same author, because oftentimes, just like when I'm writing code or Justin's doing automation, looking at the script that Justin just wrote, there were similar capabilities and similar functions that were created in both of those scripts, even though they were looking for slightly different things, because we tend to be creatures of habit. So if I'm going to write a particular payload for malware, and I'm going to, again, I know and I'm comfortable with certain things. And so again, I may use the same function calls, I may use the same strings, I may put in certain pieces of information, I may minify the code in a certain way that is consistent across various different iterations of malware. So that's one of the things I can do with Yara, is to start to deal with that. And not only can I scan files, but I can also utilize that to scan memory as well. So when we look at the overall layout of a Yara role, right, it starts with something like this. So this is directly off the website. This is the silent blanker. First, you have a rule name. Okay, so it starts with the keyword rule followed by some specific identifier. And this can be very valuable because you can name the rules whatever is useful to you as an organization. And then this can be useful for reporting. And then you can also go in, and again, you see here that it has a tag of banker, right? So we see rule silent banker is the name of the rule, and then the colon, and then followed by a particular tag. So one of the things I can do with tags is I can utilize that tag to, maybe put a MITRE ATT&CK detect capability, or a specific MITRE ATT&CK tag like T1105 or T1103 or T1027. Okay, I can provide additional capabilities so that way when I'm going through and performing my scanning and I'm taking the output of whatever tool I'm using and ingesting that into a SIEM or using that for reporting, then I can look for these tags and say, hey, do I see this particular set of rules being implemented in, being identified on a system for, looks like CryptoLocker, or looks like some type of skimmer, or some type of downloader or dropper. This can be very, very beneficial to my capabilities. Okay, so again, those identifiers, basically it works as the same convention to C programming language. Any alphanumeric character, but again, cannot be a digit. It's case sensitive, it's limited, some keywords cannot be used, those shown there, right? So all, any, contains, right? Some of those various capabilities. Okay, so then you also have your metadata, right? Now this is optional, you don't need to have any metadata, but it's very valuable information, again, for me being able to identify what are some resources associated with this, right? Does this a CVE associated with this particular capability? All right, what is the threat level for my organization? Is this being seen in the wild? Is there a particular service ticket that this is associated with it so I can track the completion of it? What version of the rule am I actually creating? So this metadata is very valuable to my environment. And then the two required mandatory capabilities are the strings. What am I looking for inside of that particular family of malware? It could be hex characters, could be regular expressions, could be just the basic strings of information, right? Just basic, text data, okay? And then the conditions, right? So how many of them am I looking for? Am I looking for, this string at least 50 times? I just wrote a rule the other day that looks for particular use of the keyword function, greater than 50 times, because this function, it created multiple functions, even with the minified code, where we went through and they started to try to obfuscate it in some way. They still had to put that code back together and then generate multiple different function calls, and that could be identified within this rule. Okay, so again, the conditions, you can say, okay, $S and or greater than this, equal to this number of conditions. You can even look for certain code segments inside of that particular file at particular locations, right? So for example, MZ at 0, right? So the indicator that this is a Windows executable, that Mike Zibikowski at byte 0 offset, so that we can say, okay, if I see this, then I know this is only for executable, right? Or this is a portable executable, or this is some type of keyword that I can use, and that gives you more granularity for that specific set of information. Okay, now as I said, the metadata is very valuable, but again, it's not required. You can have this information. You can have the description of the rule. I use this all the time to link back, so that way when I get this rule and I ingest it into my SIEM, I can use that metadata to then pivot over to other pieces of information, right? Again, if I have a CVE in there, then what I can do is I can take that CVE and then go in and pivot over to my vulnerability scanning data to say, okay, I'm seeing where there is an indicator of this machine that says that it's being, there's a Yara rule that identified that it's, to 2021, 2107. And I can go and say, is this machine actually vulnerable to that? And if so, then now it automatically raises the priority of that particular alert. Right now I have an indicator that this machine is being attacked utilizing a particular set of values that indicate that it's CVE 2021, 2017 or whatever. And then now it's vulnerable to that. So now it goes from, hey, this is a little concerning that I have an alert, but now it's actually susceptible to that particular vulnerability. Okay, you can actually use the traffic light protocol for those of you that are sharing information with other industry colleagues, right? So for example, we have the FS, Financial Services ISAC, that we share information with, And so again, there are certain rules that I say, hey, you know what? This is a good rule because it's seen in the wild. It's a very common attack. I can make it TLP white, or maybe TLP green, and then I can put that in my sharing platforms, and I can say, yes, share this with all the other financial institutions so that they can take advantage of my work. And if they want to, they can utilize it in their environment. Or I can say, you know what, this is a very specific piece of malware that is written specifically to us, and it's an indicator that we don't know. We're not seeing this anywhere in the wild. We're not seeing it anywhere. So I'm going to make it TLP red, and I'm going to say, you know what, don't share this out with anybody, right? Keep it close to the vest. Make sure you don't have any particular issues with that information, right? And then you can add in the source and the criticality. Now, the strings definition is identified by the $ character followed by whatever sequence of alphanumeric characters and underscores you want. So you define this. And normally when I'm doing this, right, I'm going to make it something that's useful to me, right? I'm going to call it, $hex or $string, or dollar, like if I'm looking for encrypted data, or if I'm looking for something that's specific, right? Maybe I'm looking for some obfuscation of particular categories. I will go through and I will generate and say, $, cowboys, right? Or $mal, $exe, whatever I'm looking for, this is going to give me the value, right? So for example, $text1 equals sample text. And then you have hex characters, hex1, right? And you look for that. You can even include wildcards, such as, the question marks there. And you can even do jumps of hex characters. You can get very, very granular with exactly what we're doing. And even, include possible multiple different hex characters, such as ORs and, just ORs right there. And you can do regex. Now, be careful with the regex, because if you're doing regular expressions, as you know, regex is computationally expensive. So you'll get alerts oftentimes that, hey, this particular rule or this particular condition is slowing down your scanning. Now, obviously, you're going to want to test this to make sure it doesn't cause any impact. But again, regex can be extremely valuable, at least in my experience, to identify specific things that are all very unique to that particular family of malware. Okay. Now, the conditions are what we do is the strings are what's inside of that particular malware, right? What's inside that process, what's inside that file. And then what we can do is we define particular conditions. Okay, again, you can do ands, ors, not. Right, so again, oftentimes you want to exclude certain things that are very commonly seen in particular code sets. Okay, so you can say this plus this, but not that. Okay, so A and B, but not C. Okay, so again, it's going to allow you to get very, very granular, right? Greater thans, less thans, not equal to, equal to. You can do arithmetic operations, right? So again, if I have this plus this or this 10 times, it's going to give you very, very good capabilities to start to identify some of this activity. Okay, you can do length matches, file sizes, and one of the best things about it is that you can look for, as I said, data at a given position. So MZ signature, so again, uint16, and then the particular hex character for that portable executable, that Windows executable, that can identify that this is actually an executable. So this, 05 or 5A4D, right? Again, that's obviously 45A, but again, that gives you the capability to identify that is an executable in Windows. Okay, and then you can also now provide that tagging like we saw with that banker. Okay, so it gives you some conditional capabilities, right? So again, the conditions are very, very good, right? Again, we're just barely scratching the surface here. But again, give me more of those conditions, because the more conditions obviously I can use that to get very, very specific and granular with exactly what I'm looking for. Okay, so again, it's just something that, again, I love to write conditions, but you want to be very careful with this because it can get very, very overwhelming very, very quickly. Okay, so writing Yara rules, again, now that we understand what it is and what we can do, the difficult part is actually writing the rules. Okay, now writing manual rules requires the ability for you to get access to various malware samples. Now, I don't really expect most of us to be, kicking at the command line or kicking it with Ollie debug and or IDA Pro and doing some reverse engineering malware, because that's really, really difficult stuff. It's really, looking at machine code and starting to identify that. Now, what you can do is just do basic strings against an executable. That's oftentimes where I start. I'll just use the Linux strings command and say, what are the ASCII readable strings I can see based upon this executable? Is there something specific and unique to that, or something within the code that I can ping off of that is specific to this malware sample? Okay, but that whole process takes a long time. Okay, because again, you have to get access to the samples, you have to do it in a safe environment. Hopefully you have a lab environment to be able to do that, so where you can detonate some of this malware and see what it actually looks like, maybe even load it into memory, and then be able to use tools like volatility to scan that memory and see what those processes are, to then use that to build your Yara rules. But again, what happens with these rules is that this process of doing this is very time consuming, and it's often very difficult unless you have extensive knowledge of doing reverse engineering of malware. Now, there are capabilities that you can take advantage of, right? You can use tools like app.any.run and Joe Sandbox and hybrid analysis that will give you some good information about that. And I oftentimes use those resources to build out my Yara rules, but then I need to test them. Okay. Now, what happens a lot of times when we're dealing with these rules is we get a lot of very broad rules, right? So again, this rule is so broad that it's just pinging off of all kinds of sample code. We do this a lot in my environment. That's why with our process, we implement a rule with, again, we put it in alert mode only, and then we go and kind of analyze it for a certain period of time and say, okay, yes, yeah, nope, it's generating too many false positives. Where can I tune this? We'll capture the PCAPs, we'll pull them down, we'll start to analyze the packet captures to say, okay, hey, where am I seeing similarities, and why is this particular thing alerting all the time? Right? We have a rule in our environment for basically, Bitcoin wallet detection, and it just, I'm telling you, it's an input into another rule, right? It's not standalone, but that thing goes crazy all the time, right? Again, we have certain, anything that's encoded is just always going crazy, because Bitcoin wallet addresses, look like in base 64 encoded strings, and we have some base 64 encoded strings that are very, very common in our environment. So again, we don't use that as the only condition, but again, that one rule then leads into another rule that then leads into a third rule that is one we actually alert on. So if I'm seeing Bitcoin wallet 1 plus Bitcoin wallet 2, or or this or that, then I'm saying, okay, all of these together can actually make me to generate my rule. Or what happens is it becomes a very narrow rule, right? A large number of false negatives, and really isn't any better, and probably even worse than just doing a file hash in and of itself. Okay, so this is where tools like yarGen can be very valuable, right? So one of my favorite providers of information when it comes to detection, right? So is Florian Rod. Now, if you don't follow Florian, if you haven't, follow him on Twitter, or if you're not plugged into this GitHub Neo23X0, I highly recommend that you take a look at this GitHub, not just for yarGen, but for a tremendous amount of resources. The Sigma tool that Justin mentioned earlier was partially created by Florian. He has an amazing set of resources that you need to take advantage of, especially if you're in the field of doing detection. Okay, now the cool thing about yarGen is it can automatically generate these rules for you. So it also includes a database of known goods. So it can say, hey, yeah, exclude all of these known goods, and allow you to actually create your own databases or inputs in the database. If you have specific utilities and code used in your environment, you can actually add to that database. So you can say, yeah, exclude all this information and look for strings that are not in this known good, right? If you have like, such as like the National Software Reference Library, you can take all of this known good code in the NSRL and say, yep, if it's included there, don't generate it. Show me stuff that's not there, but is in this particular piece of malware. Now, even with that, the process is going to still require you to tune and test your rules, okay? Because as you'll see in this quick demo I'm going to do, because I'm running out of time, I knew I'd go long anyway, is that it will, require you to, it'll generate a large number of strings that, yeah, do show up, but again, may not be valuable for actual detection in your environment. So it's written in Python, it's extensible, there's a bunch of resources there, great tutorials, and it also can create what's called super rules. Now, what you can do is, let's say I have 6 samples of Emotet that I found in various resources. So what I can do is I can then point yarGen at the directory that includes all 6 samples of Emotet or Ryuk or whatever, and say, okay, when it runs across these rules, it says, hey, not only will it generate rules for each one of those particular samples, but it'll say, here's the similarities across all 6 samples. And it generates a super rule. It says, okay, this is what I want to take advantage of. Because again, this is what the code that doesn't match my known goods, but is exhibited in every one of these particular examples. Okay, so that's really where some of the value of this as well. And it has, you know, internal scoring systems to help improve the fidelity of your rules. And it also, you know, can use this DB lookup Python script, again, which I use during manual rule creation to say, okay, hey, look for this string, compare it to the database, and show me if this string actually exists. So being used outside of yarGen, if I'm going through and doing some manual research, what I'll often do is I'll use dblookup.py and say, here's a string I believe to be unique to this particular malware sample that I've identified. And so go in and test this against the database and tell me, does it exist as a known good? Is it going to generate a large number of false positives? If so, then it may have to modify it a little bit so that it doesn't match and make it a little bit, you know, simpler, right? So let's do a quick look at. So what I've done is I've downloaded yarGen, right? And so within here, I've got yarGen. And if I just kind of show you this, right, I have a couple of YAR rules that I created, emotet, a couple of emotet rules. And then I also have a malware directory, right? So if I ls malware, you see here some crypto locker samples, some ransomware, and emotet in their own subdirectory. Okay, so again, I have these yarGen rules.yar. I'm just going to remove this here real quick because I want to show you that, you know, again, it will automatically generate this for you, right? So again, I'm going to just rm. Okay, so again, I've just removed my existing YAR rules that I have in here. Okay, and so in here is the database file. This includes all the databases that are provided with this directory, right? So again, you have good exports, you know, good impashes, opcodes that you can generate your own, and then good strings, you know, that are basically, these are just compressed, you know, databases to put together. So again, I'm going to go and just run Python, and I'm just going to show you this, and then. Okay, so again, these are some of the options you have, right? So again, tell them which particular path to scan for malware. You can specify minimum scoring. You can set a high scoring that if you doesn't want to go and deal with that. I can exclude good to exclude all those goodware strings. I can obviously create my own file. I can add my author information and references into that particular system. Okay, I can add some additional context into the particular rules I'm creating with the --score strings. I can remove the magic bytes, you know, the magic header condition statement, which is generally created to make it more granular. Here's where I would go in and add my own additional sources to the database, right? So the first thing you run when you load it is you do the update. It's going to download the opcodes and databases from the online repository, but you can also generate your own here with the, you know, the -u to update the local database, and you can give it a particular identifier. You can even have a drop zone to have yarGen actually monitor a particular directory for new samples, and then every time you get a new malware sample, you drop it in there, and yarGen will actually go in and monitor that, and then it'll create a YAR rule for it, and then delete the sample automatically. Okay, so you can automate some of this whole process in here. So if I just go through and run through this, okay, and then I'm going to do M, and I'm going to do malware, and I'm just going to do emotet. Okay, so I'm just going to monitor. I want to use yarGen to look at the emotet rule, and I'm going to call this, you know, I'm going to do an output file of emotet.yar. Okay, so it goes, first thing it does is loads the databases, right? Pulls all your known goods in there, and real quickly, just kind of show you this. Takes a little bit of time, but it's not too resource intensive. Okay, so right, it generated one simple rule, right? So all this rule was written to emotet.yar. Okay, so if I go in here, and let me go into code here. So this is my YAR rule that was created, right? So again, here's my YAR rule set, YAR generator, and you see the rule by default it generates 20 strings. Okay, now not every one of these strings is going to be a valid string for me to use in my environment. A little bit easier, but again, it gives you here the reference, and I can specify my own reference if I want, my identifier. So all of this is just commented data. So the way I work through this process is I would go through, and the first thing I would do is, again, this is the name of the executable that I actually created, right? So for example, I know this is emotet. So first thing I'm going to do is I'm going to call this rule, and I have a naming convention that we use in our environment, but it'll be like company. It's something like web. So it'd be like we have company underscore web underscore emotet, right? So I'll rename the rule to something that's more valuable to me. And here I can do something like I can go emotet, and then I can do something like apt 33, some additional tags I can add to this, right? I may want to add in here's the data was generated, the file hash is automatically created for this, right? It tells me the description, but it says emotet file. And then here, right, are the various different strings that are identified. Okay, these are the unique strings inside my environment. Like, you know what? I don't know how valuable every one of these are. Okay, so again, base class descriptor out here, well, again, I don't know if that's useful. And even sometimes it'll give you some additional information, right, as to whether or not it was identified inside of the good words. But again, this one doesn't have it. So maybe I say, you know what, for example, right, so again, the full word and the ASCII, this is going to do 1 byte per second. The full word will give me this as a full word. Look for that exact string. So I can say, you know what, the Minnesota County Attorneys Association, I don't want to provide, I don't need that. And this one as well, the Los Angeles County, I don't think that that's useful, right? Because again, it just says OS County, right? So maybe I just delete those ones, okay? And this one, I don't know, this is kind of very, random. I might just want to get rid of that because I only have one emotet sample in there, right? It may not be very valuable. Here, again, these are quite similar. I may just go through and just delete that. So my process is going to be going through and, kind of deleting some of these, so that way it's not going to be what I don't find useful. And so then I get it here, and you see the condition, right? Again, it's telling me that this is a Windows executable, file size at least 800 kilobytes, and 8 of these 20 strings. So again, at least 8 of these are identified. And so then I'm like, okay, good. So I've deleted some of these. And then what I often do when I'm generating my own rules as part of my process is I'll put in, some comments in here, and okay, like for example, oh yeah, dialogue template sample. Okay, and again, obviously this is something that I've, but again, I often like to put in my own comments in here, so that way I can go through and identify this and say, okay, yeah, this is, what this particular rule or this particular string is looking for. Because oftentimes it's regex, and if you're like me, I can write regex today, and then I can look at it tomorrow and I have no idea what that means. So again, the comments in here are valuable to me to self-document what I'm actually looking for. Because I love regex, but I really don't, find it works, intuitive to my own brain. Okay, so now here I have this rule. So then what I can do is I'll do Yara, right? Again, and I'll use emotet.yar, and then I'll do malware, and then emotet, right? And so again, within Yara, I can go and say, well, what strings match on this, right? So I'm going to do -s, and then show me what strings. And then I can do -g to spit out the tag. Okay, so you see here, it's going to give me the tags, and it says, yeah, these are the strings that were matched. Okay, so again, here, memory allocation for dialog tempo, demo aborted. It says here's the other strings that were matched against it, right? So again, S6, S7, S8, multi-edit control, base descriptor, right? So these are the strings that it matched against it. Okay, so again, that just will give me some additional details. I believe that's right. So again, he tells me malware was the one, and then emotet, because that's the string I put in there, right? The tag I put in. Okay, and so it's just telling me these are the ones that matched on that, right? So the executable here, and then the signature, and then it matched on this executable. Okay, so now if I can do yarGen again, just real quick, and then I can do -m, and I'm just going to do this against the malware, the entire malware, right? So just kind of show you this real quickly. Okay, so this is going to include my intent rules, my crypto locker samples, and some other malicious executables I have inside that entire directory. Okay, and it's going to automatically even do the subdirectory. Okay. So let's just wait for this to finish here. And so again, right, so again, here's adding rules with 53 strings, generating rules. So again, here I generated 10 simple rules and 3 super rules. And I didn't specify an output of a rule name, so it created yargen.rule. So if I go back into Visual Studio Code, open that one, and you see here's my yargen rules.yar. And again, here's my simple rules. So again, TDFB Boolean password key or ASCII. And then again, this one has all zeros at the beginning here, and then file size of less than 20 kilobytes. Okay, now here's my Rickettle Win32. So again, this is the DLL. These are some, again, some encryption. So a lot of these are just ransomware samples I found and just kind of show you, right? So here's the injector, the snake injector. So here's just some commands. And again, I'll go through and I'll say, well, are any of these strings things that I would believe would be used, would probably be false positives in my environment? And generally, I won't do this right off the bat. I'll just go in and run this. I have a PCAP of, large PCAPs of just normal traffic that I'll run it against for web or email traffic or what have you. But what I want to show you real quick is these simple or these super rules here. Okay, so here's the super rules, right? So again, this was rule 103 and 102. So these are the similarities for the 103, 1003, and 1002 executables. Okay, so this rule shows me these are the strings that are common between those two. And again, both of those are Windows executables, file size of less than 800 kilobytes, and 8 of them or all of them. Okay, so again, it's either matching on this set of conditions, it's either this, or I match on every one of these. That is a good rule to be able to use. And then for my ransomware here, again, these are the common set of rules that are across, that match all of those 3, these 3 executables, or they're just DLLs. But again, what I would go through, and my process would be to go through and then test these rules in my environment, go through and modify them, tune them, test them again, tune them, and get back to a process where, I have an understanding that this is a high fidelity rule. Again, process, right? Again, we don't know, none of us really love processes. Identify the malware through whatever means necessary, right? Your threat intelligence, whether the sharing platforms, other tools, your normal detection processes, your threat hunting capabilities, right? I gave a presentation on threat hunting a while back. Oftentimes when we're threat hunting, we find executables that just are odd. And I'll say, okay, this is something that I identified as malware. Obtain multiple samples, right? If you can not just use one sample, but the more samples you have, the ability to create those super rules becomes even greater. And then use yarGen to create your rules, super rules if necessary, then modify those rules for your environment. Go through and say, okay, this is what the automated tool created, but are any of these strings not going to be useful in my environment? Delete what's not necessary, test the rules, tune the rules, test the rules, tune the rules. And then when you feel confident, then move them to blocking and alerting, right? Because every time I have a block, I want a detection. I want an alert on that particular system. So again, in addition to just blocking, I always want a log of it, ingest that into my SIEM, put it in the dashboard. So I said, hey, this Yara rule is firing for this tool. Okay. And then again, depending upon whatever tool, you may only have the ability to detect or block, but that's the process you want to go through when you're getting these Yara rules, because there's a lot of good resources for Yara rules, but it requires, again, you just don't blindly implement in your environment. Test them, tune them, and make them work for your environment.